Let's start with the first and most important section, the different rechargeable modes for electrical vehicles. Now I'm gonna turn off the camera in order to see all the slides, okay? First of all, let's see the first rechargeable mode, okay? Which is the most basic and traditional way of charging an electric vehicle. In this mode, the car is plugged directly into a standard household socket, okay? Specifically a Suco plug. The Suco plug is the standard European connector here in Europe. And these sockets were never designed for continuous high power energy transfer. What does it mean? So the power that we can receive is very small. They are typically used for a low demand devices, okay? Low demand devices like lamps, computers, kitchen appliances, and not for something as energy intensive as charging a car battery, okay? Mode 1 operates with AC current, okay? With AC current provided from the grid, with a maximum of 16 amperes and delivers a maximum power of 3.6 kilowatts of power, okay? The voltage depends on the grid. Usually here in Europe we are talking about 230 volts, okay, more or less. This means that charging a full vehicle using a mode 1 could take between 12 to 20 hours depending of the capacity of the high voltage battery of the vehicle. Okay, the connection is direct to the cable between the plug and the car, not currently allowed because it's very unsafe due to no long recharging time. Okay, onboard charger of the vehicle handles conversion. So in this kind of mode, we talk about that the between the grid and the vehicle, we don't have any kind of communication because it's just a simple cable. Okay, so what happens if we have a peak of current? What happens if we have a big demand of power from the vehicle part? Well, the grid is gonna give this energy, but what happened? Our cable don't have the correct dimensions to support all this current, so it's gonna start to burn. Okay, that's the reason because the mode 1, this slow recharge, is not allowed here in Europe. And also, if you have a high voltage battery of ion lithium battery with a big capacity, we recommend to not use this kind of rechargeable mode. Okay, it's very important to have any control in case of a peak of current in order to stop the charging process. So in this case, as you know, every storage system, as the high voltage battery supercapacitors, are gonna storage the current in DC mode, in DC current, no, in direct current. But we are receiving AC current, alternative current from the grid. So we are gonna use our onboard charger, this component from the vehicle, in order to transform the AC to the DC current for recharge our high voltage battery. Okay, but as I said before, it's not allowed for passenger cars. Well, if you have a bike or a small vehicle like a scooter or something like that, probably you could find this kind of uh, this kind of rechargeable mode. Okay, but also you have some characteristics for the safety, for electrical safety here in the EGAN. Let's continue with the second mode. So now for mode 2, slow recharge, is very similar as the mode 1. But as you can see, here we have a device who are gonna make the difference. Okay, so let's explain this. Uh, Mode 2 is safer and smarter evolution of Mode 1. Okay, like Mode 1, this still used a standard household outlet, such as a Suco plug in Europe, but the key difference is the addition of a portable control box, also known as an in-cable control box, okay, and protection device, or ICCPD, okay, in-cable control box. This control box is built into the charging cable itself and adds a crucial safety feature. It can communicate with the vehicle using a pilot signal. Okay, so this pilot signal is gonna be the communication between the grid and the vehicle. Okay, this let the car knows how much current is available for the grid, and it can also interrupt charging if any anomaly is detected. In other words, Mode 2 provides basic intelligence in the charging process, which is completely missing in Mode 1. As you remember, we don't have this in-cable control box in Mode 1. Because of this added safety, Mode 2 is still allowed in many countries, particularly for private house use, where the charging situation is more controlled and predictable. Okay? When you buy a car, probably your vehicle is gonna come with this kind of charger. Okay, more of the manufacturers give you this cable control box. These cables usually have a maximum current rating of between 10 to 16 amperes, and again the power output is around 2.3 to 3.6 kilowatts of power. Some versions allow up 7.4 kilowatts, but only if the house installation supports it. Even though it's safer than Mode 1, Mode 2 still has limitations. Okay? First, the charging speed is very slow because, as you can see, the power that we could use here in Mode 2 is the same power that we could use in Mode 1. It's the power that the grid of our houses could give us. Okay. Second, the safety depends on the quality of the household installation. Okay. If the socket of the wiring is whole or poorly grounded, there is still a risk. So the safety of this kind of charger is gonna depend on the grounding of the grid. Okay? And third, since the charge is portable and not fixed, it lacks the stability and monitoring features of dedicated wall-mounted EV chargers. Okay? So let's gonna talk about the benefits of Mode 2. Well, the first of all, it's portability. It's useful for emergencies, for traveling, for example, or for people who don't have a garage or a wall box at home. In the next slide, we are going to talk about what is a wall box. Still, it's recommended to use Mode 2 only as a temporary solution and to upgrade to a fixed charger like Mode 3. When possible, we'll look at Mode 3 shortly. And again, like Mode 1, the onboard charger is the responsible for converting the AC of the grid into DC to charge the high voltage battery of the vehicle. Now let's continue with more technical details about Mode 2 charging. Okay, as mentioned earlier, Mode 2 is still a slow charging method, but depending on the installation and cable used, it can operate at slightly higher power levels. Most residential Mode 2 systems are connected to a single-phase grid, okay? Because everybody or most of us only have a single-phase grid in our house, which means a maximum theoretical power of 3.7 kilowatts using at 16 amperes plug. However, some installations, especially in newest houses or in places like Germany or Netherlands, allow for three-phases connections. This could deliver up 7.4 kilowatts of power using a special industrial socket like the CEE RECPAC or Type 2 with adapter. But this is only possible if both the vehicle and the electrical infrastructure support it, including the cable, no? The onboard charger and the power outlet. Let me give you a real-world example. Let's say that you are charging a Tesla Model 3 with a 60 kilowatts hour battery. Okay? Using 60 kilowatts hour battery. It's the more or less the capacity, well, the energy that a high voltage battery of Tesla could has. Using a Mode 2, okay, this Mode 2 uh, with power of 3.7 kilowatts that the grid could give us, it would be around 16 to 18 hours to fully charge from 0 to 100. Okay, 16 to 18 hours from 0 to 100%. So as you can see, it's very slow. No? So now if we use a 7.4, the time could be reduced to 8 or 9 hours, more or less, which makes overnight charging much more practical. So what we said 8 to 9 and 16 to 18 because the power is not constant. It's not always gonna be 3.7, okay? It's gonna change depending in which part of the state of charge we are. Another important factor is the charging current, which needs to be compatible with the socket rating. Some households only allow 10 amperes safely, which reduce the power to around 2.3 makes the process even slower. Okay? So to summary, Mode 2 offers flexibility and basic safety thanks to the control box, okay? But it is still relative slow, and the time required depends heavily on the available current to the type of outlet and the capacity of the vehicle battery. That's why many EV owners choose to move to a dedicated charging station or Mode 3. That is the topic that we are going to see in the next slide. Okay? So it's very, as I say, we in our houses we have another, for example, the TV, refrigerators, in the kitchen. If we have another electrodomestics, they also are consuming our electrical power. So if we have available 3.7 in our house, well, with these electrodomestics, we only have available probably only 2 or 1 kilowatt. So that's the reason that Mode 2 is just for emergency situations. And when we recharge our battery, we are going to be able to move to a bigger charger with more power capacity. Okay, let's continue. So, guys, now we move on the Mode 3, which is the most widely used standard charging method for electrical vehicles here in Europe and many other parts of the world. Okay, it's also continuous in AC current. Okay, so what does it mean? That we are gonna need our onboard charger that is gonna transform the AC to the DC in order to recharge the battery. Mode 3 use dedicated charging stations, also known as a wallbox when installed at home or as a semi-public charger in parking areas, workplaces, shopping malls, and so on. Unlike modes 1 and 2, where the connection was made using a regular household outlets, Mode 3 requires a dedicated circuit that is specifically installed for EV charging. This improves both safety and performance. Okay? One of the key features of Mode 3 is that the charging station communicates directly with the vehicle via pilot signal. This allow smart charging, load balancing, user authentications, and schedule charging. Okay, we are gonna be able to schedule our charging. For example, if you connect the vehicle and you program it that the charging start at 9 p.m., so we can do it. We can schedule the charging. Okay. The power delivered depend on the installation. In single-phase systems, we probably are gonna be able just to use 7.4 kilowatts of power. In three-phase, that is the most common in this mode, you can go up to 22 kilowatts of power, which is significantly reduced charging time. Okay. For example, let's write an example here with 22 kilowatts available from this charger. Okay, and we have a Renault Zoe with a battery of 50 kilowatts hour. Um, we could charge from 0 to 100 of state of charge in just uh, about 2.5 hours, 2 hours and 30 minutes. Okay, it's very quickly. The cable is a must in mode 3. Okay, either it's attached to the station or the driver must use their own type 2 cable. This standardization improves user safety and prevents accidental misuse. Another important detail is mode 3 charging still use the AC power. Okay, it's still using AC power. So the onboard charger of the vehicle, in still plays a role in converting to the AC to DC current. This means that the actual maximum charging power is limited by the vehicle internal charger. Okay, so depends of the capacity of the onboard charger, we are gonna receive the power supply. Okay, for instance, even if the wallbox provide you this 22 kilowatts, okay, if your car uh, if your car's onboard charger only handle 11 kilowatts, for example, okay, then that's the maximum that you will get for recharge your battery. This is gonna command you. Okay. Mode 3 represents a balance between speed, safety, and infrastructure cost. which is why it's so popular today, especially for homes charging and daytime top-ups in urban environments. It's also to recommend solution by most EV manufacturers and energy utilities when installing chargers at home. Okay, so, so continue with mode 3. Let's now look at the power values typically associated with this charging mode. The power can range from 3.7 kilowatts all the way up to 22 kilowatts depending on a few key factors. What key factors? First, the type of electrical installation, single phase, okay, single phase or three phase, first of all. Second, the capacity of the wall box or charging stations, no? So it's gonna depend of the capacity of our wall box that it could be 22 kilowatts. In most of cases, if 22 kilowatts the power capacity of our wall box, okay? And then the rating of the car onboard charger. As I said before, if you want to if your charger is available to recharge in 22 kilowatts, also your onboard charger needs to be able to recharge in 22 kilowatts. Let's break this down a bit. At the lower end, you have 3.7 kilowatts, okay, which correspond to a single phase with 16 amperes connection. This often used in older homes or where grid upgrades aren't feasible. Okay. Now, it's more common in new houses to find 7.4 kilowatts is the common for modern single-phase installation at 32 amperes. Okay, so for three phases, 11 kilowatts and 22 kilowatts are available in three-phase systems. Okay, 16 amperes for 11 kilowatts and 32 amperes for 22 kilowatts. Here's what this means for charging time in real life. With a 3.7 kilowatts of power, charging a battery of 60 kilowatts hour, it could be 16 hours. With 7.4 kilowatts, the same battery, sorry, it could take between 8 to 9 hours. ¿Vale? And finally, with 11 kilowatts, you're down this time to 5 to 6 hours. And with 22 kilowatts, full charge could happen in just 2 hours and a half. Okay? But again, these are theoretical values. The limiting factor is often the car's onboard chargers. For example, a Volkswagen ID4 might accept up to 11 kilowatts. So even if the wallbox provides you 22 kilowatts, it will be only draw 11 kilowatts. Okay. A Renault Zoe, on the other hand, can use this full 22 kilowatts, making it very efficient for Mode 3, fast AC charging. Okay. Another benefit of Mode 3 is that it's widely compatible with the Type 2 connector, which has become to a standard plug in Europe. Okay, that is something, as you can see here, this is the Menekes plug, so this is something that we are going to talk later. Mode 3 offers great flexibility with power levels that can match user needs and infrastructure. It's ideal for both homes and semi-public installations. This is for homes, and this kind of charger is for public installations. Okay, and it plays a key role making an EV ownership practical for the daily life. Okay, guys, let's continue. So finally, To finish talk about mode 3, the medium fast recharge, well, here also the single phase, as I said before, is 7.4 kilowatts as maximum, and three phase 22 kilowatts as maximum, with the actually grid here in Europe. Okay, for the wallbox. Okay, so now this our EV charger needs to be with communication with this smart sensor. Okay, this smart sensor is gonna read all the consumptions of the electrodomestic that are turned on in our houses. For example, here the refrigerator, no, the washer machine. Okay, so their consumption and then the power available for recharge our EV car, our electrical vehicle, is the the power of our home less the power of all the electrodomestic that we are using in our house. Okay, okay, let's continue. So now, guys, for final this rechargeable mode, the last rechargeable mode that we are gonna see is mode 4. Okay, now let's talk about mode 4, which is also known as DC fast charging, and it's a game charger for electric mobility. Okay, this is the first charging mode we have seen so far that bypasses the vehicle's onboard charger entirely. Why we bypasses the onboard charger? Because the charger is gonna provide us a DC current. So if we have DC current, we could pass the power directly to the battery, and we are gonna bypass the onboard charger. Okay, so directly from the charger to the battery, not use the onboard charger. Okay, uh, that's right. Unlike mode unlike mode 1, 2, 3, which use an AC power and really on the car to convert it into DC for the battery, mode 4 delivers the DC power directly to the battery. Okay, this means the conversion happens inside the charging station. Okay, so from the grid you are gonna receive the AC, and inside the charging station you are gonna make the conversion from the AC to the DC. Okay, not inside the vehicle as in the previous modes. These chargers are much larger and more powerful. With more, it could give you more power than the other modes that we see before. They can deliver very high currents and voltage far beyond what the onboard charger could handle. Okay, uh, because now the onboard charger is not working, we could introduce more power directly to the battery. This is one advantages of the mode 4. Okay, we are talking about charging powers from 50 kilowatts. Okay, 50 kilowatts uh, for fast charging 50 to 150 kilowatts. Okay, and then we could ultra fast charging, it could recharge up to 350 kilowatts. Exceptionally, we could see AC charge three phase with 44 kilowatts, but it's exceptionally case. It's not common to see this kind of power in AC. Okay, so just say that mode 4 is only DC current. For example, let's put an example. Hyundai Ioniq can accept up to the Hyundai Ioniq, the battery can accept up 220 kilowatts of power, which means it can go from 10 to 80% in about 18 minutes if the charger support it. Okay, so if we have a charger with 220 kilowatts in an Ioniq 5, it could recharge from 10% of state of charge to 80% of state of charge in only 18 minutes for the Ioniq 1. Okay, continue talking about Mode 4. Charging is used in public fast charging stations. Okay, this is for the public fast charging station, often located on highways or rest stops or urban mobility hubs. It's designed for long trips or situations where you need to charge quickly and continue your journey. It's not meant for daily overnight charging, okay? Because as I say in the battery presentation, uh, high currents is gonna uh, uh, give it's gonna start the aging of the high voltage battery. Okay, the degradation is gonna be worse. So we need to just use this kind of chargers for uh, situations when we need to charge very high. Okay. Um, These stations comes with some limitations. Obviously, the installation and maintenance costs are very high. They require strong grid connections also, sometimes medium voltage lines. Okay, so it's complicated to find these medium voltage lines uh, in the cities. Not all vehicles support high-speed charging. Some EVs may only accept 50 or 100 kilowatts. Okay, so when, for example, if we have available 220 kilowatts from the charger and our vehicle only accept 50, well, the the vehicle are gonna communicate to our charger that only give it 50 kilowatts of power. Okay, the limitation is gonna be the vehicle. What else? Mode 4 chargers are also not universal in terms of connectors. Depending of the region, you will find the combined charging system. Okay, the combined charging system, that is this plug, this connection, that is a standard for Europe and North America. And then we could find the CHAdeMO or GBT. That is it's a topic that we will see after this presentation. One last thing, DC fast charging heats up the battery, so manufacturers often limit the charging speed after 80% to preserve battery health. Okay, that's why many drivers prefer to charge from 10% to 80% of state of charge and then get back on the road. It's the sweet spot for time and efficiency. Okay. Uh, so for 20-30 minutes using this kind of chargers, we could reach 80% of state of charge of our electrical vehicle. Okay, so complex communication, yeah, the communication it's more complex because the charger needs to be uh, able to receive the communication from the vehicle. No, as I said before, the vehicle needs to communicate to the charger how much power it could accept in the high voltage battery. Okay, that's the reason why it's more complex. And also inside the charger is the isolation monitoring device. Okay, when you plug the charging the EGAN to the vehicle, the isolation monitoring device of the vehicle is gonna be turning off, and the isolation monitoring device of the charger is gonna monitoring every all this system. Okay, all this system, the charger, the cable, and the vehicle. Okay, so that's the reason why it's more complex. So here is a resume of the four modes. Okay, so mode 1 to mode 3 is AC current. Mode 4 we can say is only the DC current. This is the fastest one. These two are the slow charging. Okay. Uh, well, the characteristics from mode 1 to mode 2 are the same in most of the aspects. AC, single phase, 3.7 kilowatts. Here in mode 2 we can go to 7.4 kilowatts. Okay, but in single phase. And the most important difference is that we have the in-cable control box for mode 2. Okay, if we talk the mode 3, that is the semi-fast recharge, is also in AC, but we have the option to recharge in single phase or three phase. No, we can recharge the vehicle with 22 kilowatts power. Okay, so we have this wall box that is gonna give you the functionality of communication and also the safety standards. Now if we talk about fast charge and ultra fast charge in DC, okay, we are talking about starting in 50 kilowatts, okay, for fast charge to 150 kilowatts. And if we talk about ultra fast charge, 350 kilowatts. And nowadays we can see chargers of 400 kilowatts of power.